Hey everyone, and welcome! Today, we're going to break down a topic that sounds kind of complicated, but is absolutely crucial if you're getting into automation testing. We're talking about object-oriented programming, or OOP. And don't worry, we're going to do it in a way that's super simple and actually useful. Okay, I know this sounds a little weird, but hear me out. What if your test scripts could be as organized and easy to understand as a box of toys? That's really the big idea here. We're going to use simple, everyday things to get a handle on some really powerful programming concepts. All right, so first things first. What even is object-oriented programming? Well, when you boil it all down, it's just a way of thinking about your code that copies how we see the real world, as a bunch of different things or objects. So think about a toy car, right? It has things about it. Data, like its color or maybe a name. And it can do stuff, actions, like roll forward or have its doors open. And that's exactly what OOP lets us do with our code. We create these objects that hold on to data and can perform actions. Simple as that. Okay, think of this slide as our roadmap for today. These are the big ideas. Let's call them magic powers that make OOP so darn good. We're going to walk through every single one, starting with the absolute basics, the class and the object. So you can't build anything without a plan, right? A house, a car, anything. In the world of code, that plan is called a class, and the actual thing you build from it is an object. Let's dig into how these two really work together, because they're the foundation for everything else. Now, the difference here is it's simple, but it's so important. The class is the blueprint. It's the design doc. It defines what a browser is and what it can do. Then you've got the object. That's the actual thing you build from that plan, like the specific Chrome browser running on your computer right now. And here's what that actually looks like in some code. See up top? We define our browser class. That's our blueprint. And then using that plan, we can create real tangible objects, a Chrome object and a Firefox object. Each one is totally unique, but they're both built from the very same plan. So, get this. The big takeaway here is that you write the blueprint once, and then you can use it to create as many unique objects as you need. It's the absolute definition of work smarter, not harder. Okay, so we've got our building blocks down. Now, let's get to the really cool stuff. We're about to dive into the 4 main principles that give OOP its superpowers, especially for automation testing. So first up, we have inheritance, and this one is all about reusing your code. It lets us create a brand new class that just soaks up all the features of a class that already exists. That way, we don't have to write the same old code over and over and over again. And the best way to think about this is, it's just like genetics. A child inherits traits from their parents, right? And OOP, a child class, does the exact same thing. It inherits properties and actions from a parent class. Let's check out the code. See that little word right there, extends? That's where the magic happens. It tells our login test class, hey, go grab everything from the test setup class. That means login test automatically gets that setup method without us having to write it again. And for testing, this is huge. You can write all your common browser setup code just one time in a parent class, and then all of your different tests can just inherit it. It's so simple, and it keeps everything so much cleaner. All right, next up is a word that it sounds super complicated, but I promise it's not. Polymorphism. It literally just means many forms, and it's the idea that one action can behave totally differently depending on what object is doing it. So think about it like this. You've got a person, right? At school, their role is teacher, but at home, their role is parent. It's the same person, but they act differently depending on the situation. That's polymorphism. So in our code, what this means is we can have a single method called runTest, but it does completely different things. For a login test object, it'll run the login steps. For a signup test object, it runs the signup steps. So you have one name, but it can do a bunch of different things. Super powerful. The bottom line here is that this just makes our commands way simpler. We can just tell a whole group of different tests to run, and each one automatically knows the unique thing it's supposed to do. Okay, let's move on to our third superpower, encapsulation. This one is all about keeping your code safe and tidy. It's about bundling up an object's data and its actions together and then protecting that data from everything else on the outside. The lunchbox analogy is just perfect for this. Your food is all hidden away and protected inside. You can't just reach in and mess with the sandwich, right? You have to use the lid, a specific, controlled way to get to it. Encapsulation does the same thing for our code's data. And in the code, look for that word private next to password. That's basically the lock on our lunchbox. It makes the password variable completely hidden. The only way to interact with it is through those public methods we've defined. We have total control. So why does this even matter? Well, it's all about stopping bugs and making things more secure. By hiding that data, we're stopping other parts of our code from accidentally messing with it in ways we didn't expect. This makes our tests way more stable. And that brings us to our final superpower, abstraction. So, if encapsulation was about hiding data, abstraction is all about hiding complexity. The whole idea is to show people only what they absolutely need to see and to hide all the messy, complicated details under the hood. I mean, think about a TV remote. You don't need to know anything about circuits to change the channel, do you? You just press the power button. Abstraction gives us that same kind of simplicity in our code. We create simple buttons for really complex actions. Now, in our code, we can use this word abstract to create a kind of contract. What we're saying here is that any class that wants to be a test script absolutely must have a run test method. We're not saying how to run it, just that it has to be there. It's a simple rule, but it makes sure everyone is on the same page. And the real win here? Abstraction makes our frameworks way, way easier for other testers to jump in and use. They don't need to know all the nitty-gritty details. They just need to know which simple buttons to push. All right, we've gone through all the individual powers. Now for the really fun part. Let's see how they all work together in a real-world automation script, the kind of thing you'd actually be writing as a tester. So first, we'll create this parent class. We'll call it base test. Its only job is to handle the stuff that every single test is going to need, opening the web browser and closing it. We write this code just once. That's it. Okay, now we create our actual test, the login test. And look, see how it extends the base test? Because of inheritance, it automatically gets the open browser and close browser methods for free. Now this class can focus 100% on its one specific job, testing the login page. And that right there, that is the beauty of OOP in action. When you put these principles together, you get code that's organized, easy to read, and super reusable. No more copying and pasting the same browser setup code into every single test file. Ever again. Okay, so we've seen the theory, we've seen a real example. Let's bring it all home. Why should you, as an automation tester, actually spend time learning this stuff? Like, what's really in it for you? Look, it really boils down to these 4 huge benefits. First, you get to reuse your code, which saves an incredible amount of time. Second, your whole test suite becomes way more organized and easy to read. Third, maintenance becomes a piece of cake. If something changes on the website, you only have to fix it in one spot. And finally, it makes it so much easier for a whole team of testers to work together on the same project. You know, at the end of the day, OOP isn't just some technical thing you have to learn. It's a way of thinking that just leads to cleaner, more efficient, and way more powerful automation. So I'll leave you with this question. How are you going to use these ideas to make your next test script better? Thanks so much for tuning in.